Well, hello there. We're starting with lesson one, section or chapter one, section one here, which is we're gonna before we start this, why don't we just take a look at what this chapter is all about? This is the beginning of the first chapter of geometry, and it's entitled "The Tools of Geometry." So we're gonna look at a few things in this chapter that just kind of set the tone for all of geometry. You can see here, these are all this is our chapter preview. These are the different sections you'll be learning about. First section is just visualizing, drawings and visualizing geometry. We're going to get into what points, lines, and planes are, measuring segments and angles, angle pairs, some constructions actually, and then we'll finish it off with some, hopefully some review, but midpoint, distance, perimeter, circumference, and area. All right, just to get us into geometry. And our big questions, these are big questions. Some of them are, well, at least a couple of them are specific to one section, but they're kind of our thought questions. So the first one, how can you represent a three-dimensional figure with a two-dimensional drawing? Okay. Second one, what are the building blocks of geometry? And then the third one, how can you describe the attributes of a segment or an angle, or as we go on, point, a plane, all these things that get us into thinking more geometrical. Um, we have a number of vocabulary words that we'll be learning. I'll have you focus on certain ones in particular. So why don't we start with section one then? Section one. Um, I just want you to look at this question real quick. It just says, when you shine a flashlight on an object, you can see a shadow on the opposite wall. What shape would you expect in the shadows in the diagram to the right, and explain your reasoning? So if you look at this whole thing, this is a flat, just this whole picture you're looking at is flat, but it looks three-dimensional right here. And that's the beauty of drawings. You can make things seem three-dimensional. You can visualize three-dimensional things on a two-dimensional object. One thing that makes things look, that shows the both two-dimensional and three-dimensional aspects would be shadows. You can probably guess what this shape is right now, just from looking at this. You can guess what the shadows would be. Um, Hopefully on the left you'd think that there would be a rectangle, and on the right it would be a triangle if you're looking at it like that. But I want you to start thinking visually, thinking two-dimensional and three-dimensional. What's the difference? So our objective for today, your learning target, your learning goal, um, I'm going to put it here because I'm going to call it a learning target today, is to make nets and drawings of three-dimensional objects. So nets and other drawings. You hopefully have done nets before. So that's what we're going to start off with. A net. A net is a two-dimensional flat diagram. That's what it is. But it represents a three-dimensional figure. It shows all the shapes that make up the faces of a solid. So right here we have a graham cracker box. And I always picture a cereal box because I always unfold a cereal box after I'm done with it to fit it in the recycling. But a if you any kind of box like this, if you unfold it all the way till it's flat, you'll see it'll turn from this all the way to this. All right, and that is a net. Unfolding something. That's what a net is. Um, it's important to label the parts. Now label the side, the different measurements. So we know all these parts going from top to bottom in this middle section are 20 centimeters just from the label. We can tell that these smaller ones are going to be 6 centimeters, and then it's 14 centimeters wide in these parts right here. Okay, so that's basically what a net is. So if you were to look at problem 1, 2, and 3, and could you match the three-dimensional object to its two-dimensional net? Go ahead and see if you can figure that out. All right, remember they are all just unfolded. So if you look at number 1, it has to have a 1, 2, 3, 4. Well, I'm going to write them 1, 2, 3, 4, 5, 6, 7, 8-sided, two 8-sided shapes on there. And the only one with two 8-sided shapes is right there. And then all the sides going out from it. You could fold this thing back up to make this three-dimensional octagonal prism. That's what it would be called. So that's C. If you look at number 2, it's just all rectangles. Okay, we have 6 sides of rectangles, and here we go. Letter B has 6 sides of rectangles. And then finally, number 3, it comes to a point at the top, so there is only the one, two, three, uh, pentagonal side, so five-sided, and then they all go up into one point. So that would be A. All right. So just picture folding the net back up into a shape. What would it come out to? So why don't you go ahead and look at number 4 and draw this one. And so pause right now, and then I'll show you what it would look like. Make sure you have correct labels. There's different ways it could look. It doesn't have to be exactly the same as mine. Why don't you pause it and do that? So what I'm going to do is I'm going to make the bottom side, which it looks like the biggest side, which would be 22 inches by 10 inches. And I'm going to see what would fold out from that. So we have in this part, you have this part, actually all the sides here. So we know that this whole part is 10 inches. This whole part is 22 inches. That's what I labeled before. And we've got all these other smaller parts are 7 inches. Now, we are missing one thing though. Some might leave it like this. You're missing the top. We have the bottom and the 4 sides, so where's the top? We can attach the top to any part. It could be attached up here, because if this would fold over and still go on top. You could attach it way over here. If you fold it, it would still go on top. So just pick one of those places to show that top part. And that's going to be the same dimensions as the bottom part. Alright, one last challenge for you with a net. See if you can figure this one out. It has a hole in the middle. This one I have a really hard time doing. So if you can figure this one out, that's awesome. But I'm going to move on to our second two-dimensional drawing of a three-dimensional shape. And it's called an isometric. Oops. An isometric drawing. Sorry. An isometric drawing is a corner view drawing of a three-dimensional figure. It shows that you can see the top, you can see the front, you can see at least one of the side views. And it's done on isometric dot paper. So if you've never used isometric dot paper, it looks like these dots. They're kind of staggered dots, creating rows, or columns, and then diagonal lines if you look at it. And ultimately, it'll help you draw this type of a drawing. It's important to note that when you are drawing an isometric drawing, um, the only lines that are showing would be where the folds are. Okay, only draw lines at the folds. For instance, if you look at the right, this is the three-dimensional object that we want to draw. This line right there, this line right there, those are not folds, so we don't actually end up drawing them. Oh, and this one up here. Oops. So here's the steps to drawing something like this. It says step 1, draw the edges that surround the front face. All right. Step 2, draw a vertex from the front face and draw an edge for the right side view. So that's where you take that front face and then you start extending it. And then edges only, so here you go, it bends and folds. And then finally, draw the top, back and top edges to connect the figure. Draw all parallel lines or edges. So we're going to try, oh sorry, we're going to try this shape over to the right. It looks different because it's not already set up like this angle view. But we're gonna try and draw these parts. So this front part right here is what we want to draw first. So it's 3 blocks. So this is gonna be like 1, 2, 3 blocks. And actually, that right there is not a fold. So we're gonna go up 1, 2, and up 1, 2. So there's that front part. I only drew the folds. That's all we're drawing right now. All right, now we're going to extend it. So we want to see that back part. So this is going back one block only. One block. This is a fold as well. This is a fold. This is a fold. We're not... Well, I won't be able to see that fold. There we go. And then we're drawing the vertical lines. So the vertical lines create it like this. Well, this is actually not a vertical, but all the vertical and parallel sides. Now if you look at it, it looks like the shape, but it's on a two-dimensional flat surface on isometric dot paper. And you can actually see the front, the side, and the top. That's what you want to do for an isometric drawing. And it is tough. I will say it is tough. But one thing that I always try to remember, well, actually a couple things. I'm going to make just 2 bullet points here. The first one is that um, the vertical, that means up and down, the vertical sides or edges stay vertical. Because I know there's a lot of angling in here, but the vertical edges actually stay vertical. I don't know if you noticed that. I can show you that right here. See, these vertical sides are still all actually vertical up and down. And it's the other ones that are angled. So that's why I always start with the front. The front is going to be angled just on this slight angle, and that's why I started doing that, going this way. And then we create all the other sides that connect. All right? So that's why I was going to say the other sides, the horizontal sides, are angled. So those are my 2 notes on isometric drawings. And the last drawing we're going to look at is an orthographic drawing. Orthographic is probably the least used of all of these, but an orthographic drawing, orthographic drawing, is another way to represent a three-dimensional figure. It shows 3 separate views. So it doesn't actually show the whole shape together. It just shows the top view, the front view, and the right side view, all separated. So if I'm looking at the shape over to the right of this isometric view, pretending it's on isometric dot paper, the top view, if I visualize the top, that shaded part, all I would see if I was straight from the top would be that. That's the top view. That's what I would see. You can't see how any of these indent or not or anything. It's just that's what the top view is. The front view then, depending on what you say would be the front view, but I'm going to say this front view is like the left view. So you would see, let's see, I would see, if I'm just looking at it from there, that's what you'd see. If you turn it, that's what you'd see, because you would not tell that this part is sticking out at all, because you're just looking at it from this side. Now the right side view is probably the smallest one in this case, because all I'm going to see is that I'm going to see this, and I'm going to see this. So really it's just like a little, that wasn't very accurate. Try to be a little bit more accurate than me, but you're going to see like a little backwards L. So that's an orthographic drawing. If you're given the top, the front, and the right view, you can usually make the three-dimensional object. So here's another one. Create an orthographic drawing from the isometric drawing on the right. It's very similar. Why don't you take a second to do it? I'm going to pause it, and then I'll show it to you. So try to do this one on the right. Pause the video. So here's what I came up with for my top view, my front view, and my right view. Alright, last one, a little challenge one. If you can go backwards, draw a corner view of the figure given its orthographic drawing. That would be tough, but typically that is what you're given for an isometric drawing. You kind of see that front or that left view, the right view, and the top of it. So we have that here. Just wanted to see if you can do it, alright? And finally, oh, by the way, I'll go back and show you that in just a sec. But finally, error analysis. What's wrong with the given net for the solid at the right? What is wrong with it? Answer that question. And then why don't you go back to the original learning target And it says to make nets and drawings for three-dimensional figures. Can you do that now? Can you make nets and other drawings? What are the other drawings? Do you remember what they are and how to do them? Okay, that's all we're doing for today. And by the way, I believe this is right here what this last corner view of that orthographic drawing would look like on isometric dot paper. That's what I came up with. So that's what I'm really going to leave with you with. I hope you learned something in this section, and we'll see you next time.